Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on linear relationships and making predictions. This video includes some practice problems, and I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video. Remember in our previous example that we did make some predictions, but we didn't really test to see if it should be used because we didn't test to see if there really was a linear relationship. And the regression equation should only be used if there is a linear relationship. In the next examples, we will check for evidence of a linear relationship before using the regression line to make predictions. In example 1, we had a scatter plot, correlation coefficient. Then now we're going to look at the evidence of a linear relationship, regression line of equation, scatter plot with regression line, and predicting using the regression line. Note, the calculator must have your diagnostics on for the correlation coefficient to appear when you do the linear regression. The screenshot from part 1 of this video set on this PowerPoint had a screenshot where the R did not show up. That's because the diagnostics was not on. On this screenshot, you will see the diagnostics on. I'm hoping to have a video on turning it on. If not, do a search for one or come by the math lab and we'll try to help you figure that out. So we have another exercise that we will work together here. Which is a superhero has a cape design that allows him to fly. The following table gives the data from some capes that have been made with their lengths in inches and the top flight speed in miles per hour. If the length of the cape is 33, then his top flight speed is 22 miles per hour. For another cape with a length of 33 inches, he attained a top flight speed of 28.9 miles per hour. And instead of reading them as paired data for the rest of it, I will read the length in capes as 33, 33, 36, 36, 39, 39, 42, 42, 45, 45, 48, and 48. The top flight speed in miles per hour is 22, 28.9, 35.8, 32.5, 40, 43.7, 45.4, 42.0, 56.6, 50.6, 60.4, 58.5. Part A asks us to make the scatter plot. So using your calculator, you should be old hand now at gaining your scatter plot. You may want to pause here, input your data so that you can follow along. I'm not going to take the time to do this. Pause works wonders. B is to find the correlation coefficient. If you do the linear regression equation and pull up your screen, you should get the screenshot that's similar to what I have on the screen here. Notice with your diagnostics on, you get the R and the R squared. That gives us a correlation coefficient of R equals 0.9716. Is there evidence of a linear relationship, and explain how we know? Well, we have to first look at our scatter plot and determine if there is a linear trend, and the scatter plot shows a linear trend. Step 2, we will want to recall that R equals 0.9716. The absolute value of R is 0.9716, and with n equaling 12, our table value is 0.576. That means that since the absolute value of R is greater than the table value, there is evidence of a linear relationship. Part D is to look at the scatter plot with the regression line. And if we stored it in y1, or if we type the equation into y1, we should then have the scatter plot with the regression line. Find the linear regression line, and when rounding, we're going to use 4 decimal places here. Remember our screenshot with our linear regression, and that will give us y equals ax plus b, where a is 2.1924 and b is negative 45.6. Well, that should be 7581, not 6581. I found a mistake here. Life happens, but that should be 7581. And our equation then is y equals 2.1924x minus 45.7581. And use the regression equation line to predict the top flight speed for a cape that is 43 inches long and show your work. Remember that we can do that one of 2 ways, and she does have the correct equation here. Y equals 2.1924x minus 45.7581. And we will type that in, plugging 43 in place of x, and showing your work on your paper is that you just write down 2.1924 times 43 minus 45.7581 gives you 48.5151. And you should round that to the same number of decimal places as your original data, and that should be 48.5. Or you can use your calculator and type in y1 parentheses 43 to type in 43, which gives you 48.514. It's slightly different, but rounded to 1 decimal place still would give you 48.5. And to conclude this example, all I can think of is a phrase from a popular movie, which is no capes, no capes. We are ready to start example 2, but I am going to pause and make this the end of this video. We will pick up just where we left off in part 3 of this set.